Today's video is made possible by Dashlane. Dashlane is an all-in-one digital identity tool and password manager. Never forget a password again. Visit dashlane.com/HackerSploit and apply the promo code in the description for a 50% discount. Hey guys, HackerSploit here, back again with another video, and in this video I'm going to be showing you how to automatically embed or inject payloads or backdoors into APKs or Android applications. Alright, now we have taken a look at how to do this manually in the last two videos, where we took a look at how to decompile payloads and decompile original applications, and then embed the payloads within the applications and finally recompile the application. We then took a look at how to sign and zip align these applications so that they can be installed without any issue. Now the structure that I'm going to have for this series, as I've mentioned, is we've taken a look at how to do it manually. This particular video is going to be focused on how to do it automatically, or how to automate the process. We are then going to be taking a look at obfuscation in the next video, and persistence and port forwarding that will sort of close up the entire series. Alright, so many of you will be asking why I'm making this particular video. Well, the first reason is automating the entire process will save time, so that you really don't have to manually decompile all the applications and the payloads and then work with the Androidmanifest file. The second reason is you have a standardized process with predictable results. This is if you're using one particular tool. The variable is only going to be one, and the variable that you'll be working with is going to be the original application in which you are trying to embed the payload. Remember, the whole idea with embedding or injecting a payload or a backdoor in an application is selecting the right host application for this, and then of course when we talk about obfuscation, that also will play a huge part in the application you select. All right, and the final reason is that it is completely automated. So in the last two videos we took a look at how to decompile and recompile and embedding, and essentially the embedding process, and then finally in the next video or the previous video we took a look at the whole signing and zip aligning process with jar signer and the zip align tool. These tools that I'm going to be showing you in this video automate that entire process. All right, so now that I've essentially explained why we are making this video and the next set of videos, we can actually take a look at the tools we'll be using. Now, many of you pointed out that you can use MSF Venom to embed the payloads, although that again does cause issues with various applications. All right, now I have mentioned before in the live stream video when I covered manual decompiling and or the manual process of embedding or injecting payloads, that not all applications can or will be compiled successfully after you have embedded a payload into them, and that's because of how they were designed or how they developed. That does not mean that it is not possible. It simply means that you need to spend more time in understanding the structure of the application. So I have tried it with various popular applications over the last 1 or 2 days, essentially experimenting with some of the popular applications, seeing which one will work. And what I found out is that the most successful option is using the Google apps. When I say Google apps, I'm talking about stuff like Gmail, Google Drive, Google Docs, essentially the whole Google suite of products. And as we saw in the live stream video, I was luckily able to find that the Google launcher, the Google Now launcher, essentially gives us one of these perfect Goldilocks applications that allows you to essentially embed any type of payload you want. So that's what we're going to be using for the rest of this video. Now that we've explained all of that, let's get started. One query I had from the previous video when talking about key stores is where the default key stores are stored if you don't specify an output directory. And to answer that question, if I just go back into my home directory here, you can see that they are going to be stored in the Android, the .android directory. This is in your home directory. If you are using a different user, I'm on root, so this is just going to be my home directory, and it's under the Android directory. And you can see I have my default debug.keystore. This is going to be used for the basic signing. If you want to use your particular key store to sign, you need to specify it. Mine was on my desktop right over here, key.keystore, with the alias set to Alexis. So that's important information you need to know there. Alright, so now that we have got that out of the way, we can do it. I'll first explain how to do it with MSF, and I'm not going to go through with it because you can try it out. It works some of the time, but some of the time will give you an error with the APK tool. So for example, I can type in MSF Venom, and we use the X command to specify we are embedding or injecting, and then we specify the application we want to inject the payload into. On my desktop, I have the Google Now launcher, and this is the original one. I've not touched it at all. And then we specify the payload we are using. So the payload is going to be Android Meterpreter reverse TCP. Let me just make sure the spelling is correct here. Reverse TCP. Yeah, there we are. And then we specify options like the L host, which is 192.168.1.108, and that is unique to me. L port, which is going to be 1234, so that we keep everything standardized. And then output is going to be, which is denoted by the lowercase o command or the lowercase o parameter. And then we type in the name of the application. I'll just save it on my desktop. I don't know if this will actually work, but you can try it for yourselves with other applications. So usually what happens is, I'll just call it msfvenom.apk. What happens is the apk tool fails to recompile the application if you do it with msfvenom, and that's primarily because most of the new applications are designed slightly differently. So if I hit enter, you'll see what I'm talking about. All right, so I've hit enter, and you'll just give that a few seconds. So I'll wait for this to compile, and I'll show you the result. All right, you can see that the process isn't complete, and the last message we get, error, unable to rebuild APK with APK tool. And this looks like it's an issue with the Java JDK or either the SDK that we have now. You can see if we go ahead and look at the first error, we get a brute exception telling us, yeah, the minimum SDK version. So it's all about the SDK here. So that's primarily the error you might run into. Now, not 100% of the time, but it is going to be an error that you will face. So for that reason, I don't recommend using MSFvenom for automatic embedding or injecting of payloads into APKs. Now, let's move on to one of my personal favorite tools, and the one that I recommend you use, and that is Evildroid. So if I just open up my browser here, you can see I have the Evildroid GitHub repository right over here, and using it is extremely simple, and that's what I love, and I'll explain it right now. So you can clone the repository onto your desktop. I've already done that, and we can get started immediately. So if I just list all the files here, you can see I have it under Evildroid. So I'll just change directory into Evildroid, and we can get started. So make sure you grant execute permissions, or the execute permissions to the Evildroid executable here. And once you're ready, we just simply type in Evildroid, and we hit enter, and it's going to start it up. And again, it's going to check for internet access, and it's going to check for all the dependencies. If it does find a dependency that you don't have installed, it's going to automatically install it for you, and that's what I love. Now, the awesome thing about this tool, and why I really love it and why I recommend it, is it automates the entire process. So let me explain to you what's going on here. And it has this awesome GUI addition as well, although that may be a reason to avoid using this tool if you're doing it in an environment that does not have a desktop environment. All right, so it's going to prompt you here to start, or to essentially execute the framework and services. And we're going to say, yes, we want to do that. It's going to start the Apache and the PostgreSQL service as standard. So we're just going to wait for that to start up. Excellent. So you can see that it gives you this very nice interface here, and all credits go to the author. So you can do one of 5 options. So you can create a standard MSFvenom payload, which we don't want to do. You can then backdoor the APK using the old method, which I don't recommend. I don't think that works, or that usually works with older applications. And then you can backdoor an APK. This is the original and the new method. This works 100% of the time. If you have an application that can be recompiled successfully, this tool will do it 100% of the time. You then have the bypass antivirus APK. This is for very basic antiviruses. I've tried it before. It still isn't able to. It is still able to be detected. So again, that's why I'm going to be making a separate video on obfuscation, and it starts the listener for you automatically. You'll see what I'm talking about in a second. So if I just say I want to backdoor an APK using the new method, you'll see this. I'll hit enter. It's going to ask me, and so beautifully, to enter my local IP or the listener's IP address. And I should have blurred my public IP there. And I'm going to hit OK. It's going to ask me for my port. I'm just going to specify the port 1234 just to keep things standardized. I'm going to hit OK. It's going to ask me for a payload name. I'm just going to call it Evil APK, so that we again know what script was used to generate what APK. I'm going to hit OK. and it's going to ask you for your payload. And this is the really awesome thing. So I can specify, for example, a reverse shell if I wanted a reverse shell, but in this case I want a interpreter session and using the reverse TCP. Again, you can use whatever you want. I'm just demonstrating this for you. I'm going to hit OK. It's not going to ask me to specify the APK I want to embed or inject the payload into. I'm going to specify this right here, the Google Android launcher. I'm going to hit OK. And it's going to generate the APK payload. This is the payload generation. So it's going to open up an xterm session for us here. And it's going to generate it for us automatically. It's then going to decompile, and then it's going to decompile the original one, and then start the embedding process, and then finally recompile and sign and zip align. All of this is done automatically in a few seconds, as you'll see right over here. So now it's decompiling the original APK. There we are, decompiling the payload APK. It's going to add the permissions and hook the Smolly as we did in the manual live stream. It's going to attempt to sign the package with the debug key. That's the other important bit I told you there. So if you want to get rid of the debug key, you can change that with your the key store that you did create. All right, so you can see the backdoor APK is going to be stored in the root desktop Evildroid evil APK under evilapk.apk. All right, so what I'm going to do is I'm just going to hit OK. And it's going to prompt us to start a multi-handler here, or you can specify the attack vector, but I'm going to start the multi-handler here, which is awesome. It does it for us. So it's going to open up an xterm session for us as well here. And what I will do is once the session here is done, I will essentially start my the Apache services. And what I will do as well is I will copy that evil APK to my particular the Apache directory. Sorry about that. I got confused with APK there. Anyway, you can see that the reverse TCP handler is started. So it's going to be stored under Evildroid, Evil APK, and Evil APK. So I'm just going to copy this into the var. If I can find it here, var. We're going to go into the www directory and HTML and just put it in there. For those of you asking me to show you manually the directory, there you are. So now this already starts the Apache service for you. So what I'm going to do now is I'm just going to open up my Android device here, and I'm going to start the screen recorder. So you should see it anytime soon here. So give me a second, and let me just mute all the notifications. I'm going to start recording. All right, the screen should be up, and you should be able to see that I'm reloading the Apache web server. And there we are. We have Evil APK. I'm just going to click on it to download it. Again, saves it around the same size, which is 7.91 megabytes. I'm going to open the application, and there you are, Google Now Launcher, and hit install. It's going to install without any issues, but again, it's going to prompt us that is blocked because of the signature. So I'm just going to install anyway. Our main goal is to test and see if the payload does work. So you can still see the reverse TCP handler running there. Once I hit open, it should give us a session. It sends the stage, and there we are. We have a interpreter session. And again, just to confirm that this isn't altered, if I type in sysinfo, you can see that we are running Android 9 right over there. So for those of you telling me that it isn't working, I've just shown you that it does work. All right, so I'm going to stop the screen recording now. And that should have shown you exactly what I was talking about. All right, so that is done, and we can close this, and let's move on to the next method. Before we continue the video, let me tell you a little bit about Dashlane. Dashlane is one of the sponsors who allow us to make this type of long form content. Dashlane is an all-in-one digital identity tool and password manager that goes beyond any other password manager with its wide variety of features that aim to make your life easier. Now, if you know me, you know that I'm all for automation, and that is why I personally enjoy using Dashlane. Firstly, it allows you to automate repetitive tasks like filling in passwords by autofilling them for you in your browser. It also allows you to store your password and stores your checkout information and payment information like your various cards and various account details. Above all, it saves credentials and new signups automatically. So if you are signing up for an account, it allows you to generate a password and saves it automatically. And coming to the password manager, it also has a fantastic and secure password generator when signing up and also when generating new passwords for your accounts on a weekly or bi-weekly basis. It then allows you to sync your passwords across every device that you have connected to your account, whether it be your laptop, your desktop, or your mobile device, therefore giving you your passwords wherever you go. They also provide dark web monitoring that will alert you if any of your details or credentials are being sold on the dark web. You also get notified when a website suffers a breach so that you can change your credentials immediately. Dashlane has various free plans, but there are premium options available that you can get if you want to get more features and functionality out of the service. We have teamed up with Dashlane to provide you with a 30-day free trial, and you'll get a 50% discount on your purchase by using the code HackerSploit at dashlane.com/HackerSploit. The link will be in the description section. And with that said, let's get back into the video. Alright, the next way of doing it, or the next way that was recommended to me or to demonstrate, was by using the tool Thefatrat. Now, I wasn't going to include this tool in the video, but for some reason people keep on telling me to demonstrate it. And again, the problem with Thefatrat is it's not really designed to create backdoors on Android, and I'll show you why in a second. So I initially was only going to demonstrate the MSF Venom method, Evil-Droid, and finally Apkinjector, which I'm going to show you after I show you the Thefatrat. So talking about the Thefatrat, again, I have it cloned to my desktop. I'll also be posting the links in the description so you can check them out for yourself. So I have the Thefatrat right over here, and I've already set it up. So for those of you asking me how to install it, really is very simple. Just browse into the directory, make sure that all the executables have executable permissions, and run the setup.sh file. What that will do is it will install all the dependencies required. Alright, so once that is done, it'll also prompt you as to whether or not you want to have a universal shortcut. And that means you can simply type in Thefatrat anywhere in any directory, and you'll get the Thefatrat launcher right over here. So there we are. You can see that it is copyright to 2017. That's what I was trying to explain. It hasn't been updated for a while. So again, it's going to check dependencies, and if you don't have a particular dependency installed, it's going to install it for you. And it gives you this little this nice little warning telling you not to upload any of the backdoors to virustotal.com, and do not do that. And I'm going to hit enter, and it's going to start the PostgreSQL service. I'm going to hit enter, and there we are. So with Android, we want to talk about backdooring an original APK, which is option 5. So I'm going to specify that, and I'll show you what the issue is here. So it's going to clean the temp files. I'm also going to blur my IP address right over here, my public IP address. It's going to ask me to set my L host. I'm going to set that, which is pretty cool. Set the port, and then it's going to ask me the path to my Android app. This is my original one, so that is going to be root desktop. And because this does not enable auto completion, I need to actually go into my desktop and copy the entire name here. So there we are. Copy the entire name, and I'll paste that in here. Whoops, sorry, that did not paste. There we are. Hit enter, choose the payload. Again, this offers us that option, which is great, and this does work in a terminal, but you'll see what I'm talking about when I tell you it doesn't work. So I'm going to specify option 3. Alright, so it's going to start the process. I've tried both of these methods before. Used backdoor APK 0.22. Let's try that, and you'll see that it does give me this this error. Alright, so it's going to start creating the rat APK file. So we're just going to give that a few seconds. Alright, so the decompilation has begun, and that is the rat APK file. I'm not too sure what APK it's currently decompiling, and that's primarily why I don't like using the Thefatrat for Android backdoors. Get that correct. I use the Thefatrat for a few other backdoors, but not really for Android. So it's going to decompile the original APK file. Alright, so it did explain. So it essentially decompiled the payload first, which is what you should be doing. Alright, it's going to run ProGuard, and again, for those of you who don't know what ProGuard is, it's something I'm going to be covering in the obfuscation video. ProGuard allows you to obfuscate your Android APK, which is good. It tries to do that for us here, which is pretty cool. However, it does not, or is not able to essentially backdoor that particular APK. And there we are. The reason it tells us right over here, failed to recompile the original project with backdoor, is it was unable to verify the application signatures. And if that happens, it means you should try it with another application, or at the very least, you should just test and try what applications are able to be compiled, decompiled, and then of course with the inclusion of ProGuard, that may be one of the issues as to why we are getting this error. So again, we are not able to generate that particular APK. Remember, we have been able to do it manually. We have been able to do it with Evil-Droid, and now of course I'm going to show you how to do it with Apkinjector, which is also one of my personal favorites. It's a true OG for those of you who know how to use it. So I'm going to exit out of the Thefatrat. No disrespect to the Thefatrat, it's great for creating Windows backdoors, all of that good stuff. And I'm just going to hit 17 to exit and hit enter. I'll also be making a video on the Thefatrat, just exploring it in a post-exploitation environment and also for persistence. I'm just going to exit out of here. And again, the last tool, as I told you, that I'll be going over is going to be the APK injector, which is right over here. Don't worry if it tells you that it is, it's going to tell you to use APK wash. APK wash is mainly designed for obfuscation. Again, I'll be covering that in the next video. When we talk about obfuscation, I have a lot of ways I want to show you there. And so you can clone this into your desktop, and I already have done that. So again, I'll list the directories on my desktop, and looks like we have it. Where did I save it? There we are, APK injector. So APK injector. I'm just going to change directory into that folder. And if we list the files again, it's just going to prompt you with an executable. So grant it executable permissions. And once you're ready, just hit launch. But before you do that, it does not have an interface. This is all a manual specification. And I would say APK injector works 80% of the time. And that's because it actually does prompt you to specify the smally file for the main activity. All right. I'll explain this in a second. Now, if I just simply type in APK injector, it's going to tell me or prompt me to specify the options here. So it's going to tell me to generate the payload first, and then I specify the payload and the original application. All right, so that is the structure. So I'm going to say APK injector. I now need to specify the directory to the payload that I created with MSF Venom in the first video, which is on my desktop, and it's simply called payload.apk right over here. I then need to specify the original application that I'm going to be inserting or injecting this payload into, which is going to be the com.google.android launcher. And then once I've done that, I simply hit enter. Now you'll notice some very interesting things happening here. So it's going to start loading all the resources, decompile. There we are. Now it is going to tell us here, was unable to locate the .smally launcher in the Androidmanifest.xml file with the current grep command in place. This is what you call a beautifully designed script. It does not assume anything in regards to the main activity or the .smally launcher. And that's why I had to make the video showing you how to decompile and how to embed payloads manually. So if we go back into the decompiled into the decompiled application folder, which I renamed original decompiled, and as you can see, that was accessed on Saturday, or created on Saturday, sorry. So if I go in here and I open up the Androidmanifest.xml file, and I told you the two lines you're looking for are the android.intent.action.main right over here. That's primarily the most important one, and you want to look for the top class here, and that will refer you to the smally file that you should be using. So right over here, we are able to get the destination or the directory of the smally file that we are going to use, which is under com Google Android launcher, and it is called stubapp.smally. All right, so let me show you that right now. So com, if I go to smally, com, Google, and this is the stage. Remember that we had set here the Metasploit stage when we embedded the payload manually. So Google Android launcher, and we're looking for the stub app right over here, stubapp.smally. So that is the smally file that we need to specify here. So the directory again is going to be it's going to be smally com Google Android launcher. I'm just going to copy this. All right, so there we are. Copy that so that I know the name. So it is smally com Google Android launcher. So smally com Google Android launcher, and we paste in the name right over here and hit enter, and of course there we are, successfully injected the payload, and the invoke was inserted into the launcher, and there we are. Fantastic. All right, so it also signs it for us, which is awesome, and it signs this with the debug.keystore file. So remember, if you want to replace it, go ahead and replace it there. All right, so the application is completed, completely signed, and we can actually get started. So if I list the directory here, we have the injected com.google.android launcher. So I'm just going to copy this injected, and I'm just going to save it to my Apache directory here, which already has the Evildroid APK. Let's start the Apache 2 service here. Start that. All right, and we've started that up, and we can get started. I'm gonna bring up my screen recorder any moment now. So I'm going to start that up right now. So that should be up. So I'm going to reload the web the web server here. We have the injected APK here. Now before we do that, I'm just going to stop the recording and I'm going to delete the previous Evildroid APK because I didn't do that for some reason. So just give me a second here. So I'm going to delete it right over here, uninstall, and that's good. All right, so now we can I should have resumed the recording now. All right, so I'm just going to refresh that one more time, and we're going to download the injected com.google APK again, same size, and I'm going to hit open like so, and there we are. It's going to prompt me to install the Google Now launcher. Hit install, and again I have to set up a multi-handler. Install anyway. All right, the application is safe and we can start our multi-handler here. So use multi-handler. Actually, that is the exploit multi-handler. Sorry, exploit multi-handler. Show options. We haven't set the payload yet, so set payload Android. That's interesting. Show the options. Set. Yeah, I think I set lhost here. Oh yeah, I specified the equal sign. Sorry about that. I thought I was still generating payloads with the MSF Venom, script. So change this to L port as well. 1, 2, 3, 4, and we can run that. And we've started the reverse TCP handler. I'm going to start another screen recording here, and I'm just going to hit open, so we can see that the stage was sent and the Meterpreter session was started. And again, to verify that this is working, I'm going to type in sysinfo, and there we are. We can see we're still running Android 9, and there you are. So for those of you asking me whether it did work on Android 9, you can see there we are, and I've shown you various methods in which you can automatically create these backdoors in APKs, or essentially automatically embed these payloads in APKs. So for those of you who were really curious on this video, there you are. And now for those of you who are interested in obfuscation, setting up persistence and port forwarding, those videos are coming on up right after this one. So again, that's going to be it for this video, guys. Thank you so much for watching. If you have any questions or suggestions, let me know in the comment section, on my social networks, or on the forum at hackersploit.org, and I'll be seeing you in the next video. Peace.